Hello everyone, welcome back to my YouTube channel. In this video, I want to continue to solve the next three questions, which is question number 13 until question number 15 from EJU Physics 2019 first session. You can check link on the description box below if you want to watch the solution for the other problem on this paper, or check my EJU playlist for another paper. Okay, let's start from this question. In this question, we have a point charge with a quantity of electric Q is fixed in a place at the origin of an x-axis. So I have a charge with a electric charge Q and I put it on the origin. And then I have another point charge. The electric charge of this charge is negative 4Q, and I put it on the x-axis where x is equals to A. This is my second point charge. Excluding infinite distance, are there any point on the x-axis? So we focus on the x-axis where the magnitude of electric field is 0. If there are, how many axes in what range? From 1 until 8 below, choose the correct answer. So my goal is I want to find the position of any point where the magnitude of electric field is equal to 0. To solve this question, we have to know the direction of electric field. The concept is, if I have a positively charged, then the direction of electric field is out from that point. So the electric field is out from that point. We just focus on horizontal direction in this case. And if I have negatively charged, the direction of electric field is into that point or into that charge. Once again, we just focus on the horizontal direction. So, since I have positively charged here, the direction of electric field is out from that charge. If I draw by using my red highlighter, this is the direction of electric field produced by this positively charged. Out or away from that charge. Out or away from that charge. And then for this negatively charged, if I draw the electric field by using another color, it will goes into that charge. So something like this. Hopefully you can see, goes into that charge. If we focus on the three regions, the first one is this, the second one is this one, and then the third one is this one, you can see that our red line is go to the left. This is the electric field produced by Q, and then our blue line is go into the opposite direction. This is the electric field produced by negative 4Q. So I think since the red one is going to the left and then the blue one is to the right, I think this position is possible. So if I assume this one, this is the point where we want to find the electric field, my red line is go to the left and then blue line is go to the right. So this point, basically this point is in this x-axis, yeah, but I draw it a little bit higher so we can see it clearly. So this point is possible to produce electric field is zero, because one field to the left, the other to the right. How about the region between these two charges? If you see, the red one is go to the right, and then the blue one is also go to the right. The electric field in this region will adding up. So it is impossible the magnitude of the electric field is zero in this region, because the direction is the same. The blue one go to the right and the red one is also go to the right. It will adding up here. The red one is go to the right, the blue one is also go to the right. So impossible in this one, or in this region. And then for the third region here, the red is go to the right and the blue is to the left. So I think by considering the direction only, it is possible to obtain electric field equal to zero in this third region. So it is possible here, it's also possible here, by considering the direction only. But if we try to calculate it, the only possible region is this one. I will show you the calculation. First of all, I will assume that the distance from this point to origin is x. So assume this is x, the distance is x. And then I will try to find the value of x. If I got the value of x, that means this position is possible. So I will try to find the value of x. This is the electric field by Q. I will assume it as E1. And then this is the electric field produced by negative 4Q. I will assume it as E2. For the electric field to become zero, then E1 must equals to E2. E1 must equals to E2. The formula of electric field is KQ over R square. This is the formula to calculate electric field. Capital E is electric field, K is a constant. The constant is 9 times 10 to the power of 9. And then Q is the charge that produced the field. And then R is the distance from the charge, to the position where we want to find the field. That is R. So E1, if I want to calculate E1, I can use this equation K times Q1. Q1 is Q. Remember ya, E1 is electric field produced by Q. So the charge is Q over R square, the distance from Q to this point, basically X, must equals to E2. E2 is electric field produced by negative 4Q. So by using this equation, E2 is equals to K times 4Q over the distance from 4Q to this point. So I need to know this distance. Of course, this distance is a plus x. So r is a plus x being squared. A plus x squared. And then I can cancel out k, divide by k on both sides. I can cancel out q here, and then take a square root on both sides. Square root of 1 over x squared is 1 over x. And then square root of 4 over a plus x squared is 2 over a plus x. If you cross multiply it, you will get a plus x equals 2x. Then x is equals to a. Since I got the value of x, that means this position is possible. But if you try to do the same thing in this position, you will not get the value of x. You can try it by yourself, yeah? At the end, you will get the value of x here is negative. So this position is impossible because your value of x is negative blah blah blah. Of course, we do not have negative in distance. So this position is impossible. So my answer for number 13 is there is only one possible position, which is a less than, one position which is x less than 0. So the position is somewhere here, x less than 0. This is the origin, yeah? So this is the negative value of x, or negative coordinate of x. So my final answer is number 7. Okay, let's move to number 14. As shown in the figure below, a spherical conductor with a positive electric charge Q is concentrically placed inside the cavity of an uncharged hollow spherical conductor. So you have a spherical conductor with a positive electric charge plus Q. From the diagram, this is plus Q is placed concentrically. That means you placed it at the center of an uncharged hollow spherical conductor. This is the uncharged hollow spherical conductor. Due to electrostatic induction, a charge negative Q develops on the inner surface of the spherical conducting shell. So negative Q is here, and then a charge plus Q develops on the shell's outer surface. Plus Q is here. I will write it down like this. This is negative Q. Negative Q is spread out along the inner shell, and then positive Q is spread out along the outer shell. From 1 until 6, choose the best represents electric field lines within the cross section including the center. So if you remember the previous question, I already mentioned that the direction of electric field is out from positive and go or into the negative. Since this is positive and the inner shell is negative, so the electric field is out from positive, go into the negative. Something like this. So the possible answer is number 2. Number 1 is definitely incorrect. Number 3 is definitely incorrect. So my choices is 2 and then 4 and then 6. 2, 4 and 6. And then since the outer shell is positive, if you remember, the direction of electric field is out from positive, go or in to the negative. So since this outer shell is positive, so the electric field will out from that positive Q. So my choices or my final answer is number 2. My final answer for question number 14 is 2. Let's proceed to the last question, number 15. Number 15, I have a battery with EMF 9 volt. This is the battery. The EMF, electromotive force, is 9 volt. And then I have two resistors. The resistance is 500 ohm and 3000 ohm. And another unknown resistance R. This is 500 ohms, this is 3000 ohms, this is the unknown resistor. The resistors are connected as shown in the figure below. The connection is like this diagram. The magnitude of electric current flowing through point P is 6 milliampere. 6 milliamps is the current flow through point P. The internal resistance of the battery is negligible. The question is, what is the quantity of electric power in milliwatt consumed by R? We want to find the current in this resistor. Since we want to find the power, of course you have to remember the formula of power. The basic formula of power is V times I. V is potential difference or voltage, I is electric current, P is power. And then if I combine it by using Ohm's law, Ohm's law states that the resistance is equals to V over I. If I combine the formula of power and the formula of Ohm's law, we can derive another formula for power. As you can see, if I substitute V equals to IR into this one, you will get power is equals to I square times R. This is the another formula of power. And then if you see from this equation, I know that I equals to V over R, and then substitute it into this, then I got power is equals to V square over R. So basically, these are three equations that we can use if we want to calculate power. So if I want to find the power in resistor R, I need the PD in this resistor and the current in this resistor. Of course, the PD is not equals to 9 volt because 9 volt is the total potential difference of this circuit. And then the current that is flow through this resistor is not equals to 6 milliampere. How do I know? Because if you see the current here, it will split up. So if this is 6 milliamps, this two things or these two current is not equals to 6 because it will split or divide into 2. We do not know whether it is split equally or not. So we need to analyze the circuit first. First of all, since I know the current is 6 milliampere here, so I know that the current that passes through 500 ohms resistors is also 6 milliampere. Since I know the current and then I know the resistance, I can find the PD across this resistor by using the Ohm's law. By using the Ohm's law in this resistor, I will get 0.5 times 10 to the power of 3. This is the resistance R is equals to PD V over I. The current is 6 milliampere. Milli is 10 to the power of negative 3, yeah? If you cross multiplying it, you can cancel out these two things. 0.5 times 6, you will get 3 volts. We already know that this resistor has potential difference 3 volts. The total potential difference is 9 volt. So you can think like this. You have 9 volt here, you have 9 volt here, and then this 9 volt is being used 3 volt by this resistor. This resistor used 3 volt out of 9 volt. Then the rest are 6 volts. Since these two resistors are connected in parallel, as you know, if you have a parallel connection, the PD is the same. So since this one used 3 volt, then these two resistors is used 6 volt. The total should be 9 volt. So V equals to 6 volt here, and then V equals to 6 volts here. Since it is parallel connections, yeah, in parallel connections, the PD or the voltage must equal. And then, since I know the PD in this resistor is 6 volt, and then I know the resistance, I can find the current that is flow into this resistance. By using the same equation, I will get R is 3 times 10 to the power of 3 is equals to V over I. I can find the current that flow through this 3000 resistor. I will get I is equals to 6 divided by 3000. You will get 2 times 10 to the power of negative 3 ampere. So I is equals to 2 milliampere. Current that is flow through this bottom circuit is 2 milliampere. And then if you see, the total current is 6. So this is 6 milliampere. And then 2 milliampere go to this resistor. That means the rest, 6 minus 2 is 4. 4 milliampere go through the upper circuit. Now we already know the PD across R is 6. And then the current that passes through R is 4. By using the first equation, I can find out the current. So if you see from this two information, you will get power is equals to V, which is 6, times I, which is 4 milliampere. 6 times 4 is equals to 24 times 10 to the power of negative 3. 10 to the power of negative 3 is the same as milli. The unit of power is watt, yeah? So my final answer is 24 milliwatt. The answer is number 4. Okay, that's it for this video. Thank you very much for watching this video till the end. I hope I can see you guys on my next video. Bye bye.